So now we'll switch gears from talking about specific features of Azure products or Azure services to actually thinking about how to actually build your own solutions on top of Azure. And we have a great speaker for that, Saravana Kumar, who's actually done that himself. So he's going to talk about his experiences. All right.
Thanks, Carl. Okay, good morning, everybody. So how are you doing? Second day is always tough, right? Okay, let's get started. As Carl mentioned, I think the whole of yesterday, like people were discussing about a lot of small things like Azure Functions and App Insights and bits and pieces all over the place. But I think most of you guys are coming from a corporate background, and what makes it building a complete solution in Azure, like what are the different things involved in making it happen, is what I'm going to talk about today. Just to give a brief intro about myself, do anybody know me before? Okay, so my name is Saravana Kumar. So I'm a long-time Microsoft MVP. Like I'm coming from an integration background. So I used to be a BizTalk MVP since 2007. It's 10 years now since I got my first MVP. And then they kept switching it, and in between they called connected systems. And now I think everybody is a Azure MVP. So whatever you do, you're an Azure MVP. I'm also a founder of a company called BizTalk 360. It's actually a product that sits on top of Microsoft BizTalk server, and we provide a lot of value-added services like monitoring operations and analytics and those kind of things. So that's my Twitter handle and my email addresses. So if you want to contact me after this talk, feel free to just reach out to me anytime. It's not a problem. So today's talk is about building a SaaS-based product on top of Azure. So anybody coming from a startup background here, like you're trying to build a SaaS product, something like that? Okay, one there. Okay, it's good. Okay, so we have built a couple of products now. So BizTalk 360 is an on-premise product that's been in the market for 5 years. But a couple of years ago, we decided to had some product ideas, and then we decided to spin off like a couple of SaaS-based products. And it took us a long time to figure out the right kind of technologies, what we can use and how we can, make the solution scalable and all those kind of things. And that's going to be the talk for today. So these are the two SaaS products we have. So BizTalk 360 Cloud, it's a lighter version of BizTalk 360. And Service Bus 360 is a brand new product which sits on top of the Azure Service Bus. So what we provide is we provide a lot of operations monitoring analytics capabilities on top of Service Bus, because Microsoft is good at providing the platforms. Normally, they don't invest quite heavily on the toolings on a specific platform. So we believe messaging queuing is going to be one of the core technologies that's every single enterprises will use. And we wanted to make sure that the tooling is sufficient for big enterprises to take care of it. So yesterday, I remember like a lot of people lifting your hands for using Service Bus, and also that's a common thing. Like most of the people, when they say they're using Azure, Service Bus comes as number one, basically. Like they will touch base, they'll use some queues, they'll use some topics and stuff like that. So hence we decided to go ahead with that. So there is you can sign up when you have time. But today we are not going to go anything into the product itself. It's all about Azure and the technology behind how we build the product itself. Okay, for people who are not familiar, like what is a SaaS product, you might have heard this terminology, like a SaaS-based application is getting more and more traction, and I think it's getting very popular these days. Like the traditional model of people paying upfront everything for a software is slowly diminishing. Like people wanted to take it as a service, and they wanted to start using it as and when they grow or the requirement grows. And this is actually it's a very good representation. Like it's been in the market for a long time. I think somebody put this very good example like 2-3 years ago. to differentiate, how can you differentiate like a complete on-premise solution to a SaaS-based solution? So here is a pizza example. So if you look at, if you're going to make a pizza completely at home, so you need everything, right? So you need an oven, dough, water, soda, dining table to sit and eat, and everything. So that's a classic on-premise solution. So where you build everything in-house. And then the next it goes to like IaaS, infrastructure as a service. So in our world, it's similar to running, hiring a VM from Microsoft Azure and putting our stuff into that platform. So in that case, half of the load is taken care by Microsoft and whoever the VM provider is, but the solution, maintaining it and maintaining those VMs, or all those things still fall under your responsibilities, and that's where the IaaS model comes into picture. And the third is a platform as a service, and there are a lot of services in Azure now, which is a platform as a service thing, like a Logic Apps is one. So where you don't really worry about infrastructure, you just go build some Logic Apps, do some connectivity, and then you deploy it and run it. Even when you compare the Azure functions, Timo was talking before, like it's a platform as a service. Like you don't need to worry about the hardware, you don't worry about the patching the servers and all those kind of things. And that's a PaaS model. But still, you need to do some stuff, you need to build your things, and then you need to deploy it. But whereas SaaS is, you really don't worry about anything. You only worry about your data and your way of working with it. Salesforce is an example, Dynamic CRM is an example where, you really don't care about building anything. You just, start using it. And that's getting more and more traction because the CapEx cost of upfront investment is low. They typically grow in the model of either you pay per user or a pay per agent or something like that. So that's how we designed the new products, and we'll go into a bit more detail. So what are the key characteristics of a SaaS-based product? So the number one is a scalability. I'm talking more from a technical background, being you are the provider of a SaaS-based solution, and what are the things that's important from your point of view, like you're building a SaaS-based product. So the number one is it should be scalable both technically and financially. So what it means is the technical scalability is everyone is aware, as and when you grow your customer base, you want the solution to grow smooth as well. So you do not want to upfront invest in 20 different servers thinking you will get 100,000 users in next 6 months. So because that's a very expensive way to do it. So instead, you wanted to start small, but you wanted to grow step by step. And how can you design that? That's the number one thing you need to worry about in a SaaS-based thing. Financially, it's important as well because most of the startup companies, you have very little funds at the beginning, so you need to be very optimized in terms of how you can't just burn it if there is no need for it. So you need to think about it. Reliability is the second biggest thing because you agreed, you host and maintain and everything, so that you cannot afford to have any downtime. If even if you have a short period of downtime and in a multi-tenant system like a SaaS product, it's a brutal. So you just need to make sure it's near 100% reliability. You cannot have any leverage for a downtime. Even your upgrade should be smooth. Your bug fixes and anything you do in the platform should be as smooth as possible. So you need to take care of that. Smooth onboarding process because the way you scale things is, nobody's, we wanted to make the user to come on board and start using your product as smoothly as possible. You don't want, a salesperson calling somebody and say, this is how you sign up for this, or this is how, you add resources into this. You need to make sure as simple as possible so that the adoption rate will be quite high. And you also need to make sure tenants are isolated. I mean, the customers, when it's a multi-tenant application, and you wanted to make sure there is a clean boundary of separation between each one of those tenants, because it's it's too risky, like a developer putting a wrong join somewhere shouldn't expose one customer's data to another customer's data. So it's a tremendous amount of thinking should go in how you're going to separate your tenants from each other, and less time to troubleshoot and fix. That comes to the same reliability problem. So it's a software, and at the end of the day there are going to be bugs here and there. It's all about like how quickly you can react to it, how quickly you can fix it. It's very important, and this thinking process should come right from your design phase. It's not the afterthought of because right now most of the people building solution, these things will come as an afterthought. Okay, we'll have log files and stuff like that, but when you're building a SaaS based product, it should be on as your number one priority. Like, how are you going to support it, how are you going to fix it, all those kind of things. Continuous delivery, so you might have already noticed in Azure or any things, they ship every day. Pretty much new things gets into the platform each and every day. Like in Azure, we know they do multiple times within a day. Again, you need to think up front, like, how are you going to design that thing so that, you can have continuous deployments and you can push things into production in a smooth way. The only way you can achieve that is full 100% automation from day one. So once you have like a manual thing somewhere in the process, it slows down everything, and also it's prone for errors. And there's also the payment thing, which is not really technical, but that's also something you need to take care of as a SaaS product, because the whole thing of SaaS product is we are not going to send a purchase order and ask for speak to a human being to get the payment. So payment is one of the core parts of the SaaS product. So now let's get deep into what are the things we used in Azure to build the SaaS-based products. So we were also very conscious, even though there are hundreds of services out there in Azure now, you don't really need to use all of them for your requirements. So you can pick and choose the right ones. We feel the more the less things you use, it's better. So otherwise it becomes uncontrollable in terms of all these different things, and you can easily get spoiled. Okay, let's go and use Azure Functions or something for this, and Logic Apps for this and that. But it's better to keep it controlled and say, okay, these are the 10 different things we are using, and this is how our solution gets structured. So we use Azure App Services, so that's used for a couple of things. So we use the front-end layer, the web apps are hosted in App Services, and we also have a bunch of back-end services, like a back-end, like a roles kind of things. So we use that App Services as web jobs in App Services for that as well. And Azure Event Hubs is something we use. So that's for the ingestion of the messages into Azure. And of course, we use storage for some storage purposes like scripts and stuff like that. Azure Vault is used for certificates, so you need to make sure it's secure, HTTPS and all those kind of things. We use Azure Vault. Web jobs have got a lot of backend processes that runs on as a web jobs, and SQL plays a very important role. Of course, it's a lot of data, and you need to store it. And what's interesting is we used a capability called SQL Elastic Pool, which I'll discuss quite in depth. That's one of the core bits of the whole solution, like how the model works. So these are all the building blocks we have in Azure. And we also have some external third-party products as well to support us in certain areas. For example, I mentioned payment. We need a mechanism to collect payments from people, so seamlessly using credit cards. So we use Stripe. So a lot of people might be aware, a Stripe is a payment gateway. So they takes care of credit card processing. It's actually started by a couple of guys in Ireland, and I think they are the youngest billionaires in Ireland. So they've grown significantly in the last 3 years. ChargeBee is another company which takes care of subscription-based billing. For example, you need once somebody gives a credit card, you need to get a recurring payment every month. Takes care of refund, cancellations, upgrade, downgrade, all those kind of things. So we kind of outsourced it to that. That's another third-party product. SendGrid, some of you might know, we send a lot of emails. It's a monitoring product. So we send literally thousands of emails. So, don't do the mistake of having your own SMTP components to send emails, because you will quickly be blacklisted at the amount of volume of messages you're sending. So you need to use a reliable third party to do that. Okay, let's get into the architecture a little bit. So I'm going to discuss in parallel both the products, BizTalk 360 Cloud and Service Bus 360. So we reused pretty much everything. A majority of the stuff is reused in both the products. So it's only there are slight differences, so that that's why it's worth mentioning how we have built it. So if you look at this picture, let me explain briefly what this product BizTalk 360 Cloud does. There are lots of customers using BizTalk server, and their BizTalk servers are actually hosted on their on-premise data centers. So it's not on the cloud. So the customers run their BizTalk environments in their own data centers. So what we have done is we have built an agent, so which will get deployed into those BizTalk servers, and those agents will pump in the data to the cloud. And once the data is in the cloud, then we have the entire platform where the users can log in, they can configure their monitoring, and they can get alerted. All those kind of things happens. So this is what you're seeing here. There's a lot of agents pushing data to the cloud via event hubs, and we have a bunch of core web jobs which process the data and then sends it to basically the relevant the databases. So this is very high level picture. I will dive deep into how things are working together. So you can see there is a core database, there is a web front end, and the customers log in via the web front end, and a bunch of customer specific web jobs and customer specific databases. So this is the Service Bus 360 architecture. So if you look at it, it's pretty much, the Azure part is pretty much reused. So only in the Service Bus 360 case, we do not have agents. Of course, we are not dealing with the on-premise BizTalk customers here. Instead, what we are dealing with here is we connect to the customer's Azure subscription, and we pull data from their service bus configuration into our platform. So it's a slightly different model, but it's pretty much more or less it's the same. So you have the customer Azure subscriptions on one side, and within our Azure thing, we have the same kind of architecture. We have a SQL pool, a lot of web jobs, storage, and web applications, and all those kind of things. Okay, let me discuss a little bit about how that the agent to the data communication happens. So if you look at it this is just one flow. So you have the BizTalk agent which is running on an on-premise solution. So you deployed an agent. So the agent will have two important communication things. So one is they talk to Azure event hubs, and that's where they constantly push data. Every few seconds it's a configurable thing. Every few seconds once it sends a bunch of metadata from that particular BizTalk environment up to the cloud, and that goes to the event hubs. And from that event hub, we have a couple of backend processes which pulls the data from the event hub and then push it towards the corresponding databases for that particular customer. So we have a unique when you install the agent on that particular local machine, you have a unique ID for that agent, and that ID plus additional metadata that comes in the message will determine where the data should go and to which database it should go. So all those things are routed correctly, and then and goes through. And we also have the agent also talks to a web API. So that's for some of the maintenance two-way communication kind of activities. So we maintain an API. So it will constantly talk to that API and then figure out a bunch of items. I got it in the next slide. Okay, so I think the first thing is, why did we choose event hubs? What problem does it solve? Okay, event hubs is relatively new. I think it's been there maybe two and a half years, something like that. So imagine if you don't have event hubs, your solution will look pretty complex. But if you think about, like you're going to get data from literally thousands of agents, and it's going to a central place, and you need to store it in a data store at the back end. Building that layer is very, very hard. Traditionally, people, they would have built it like they put a web API on a virtual machine and then have a load balancer at the top, and then it takes the data and then distributes it. And you need to worry about things like scalability, high availability of that endpoint so that it won't fail. All those complexities are taken away by using Event Hubs, because Event Hubs is designed for that kind of thing. In fact, Event Hubs is designed actually mainly for, I think Sam mentioned yesterday a little bit about IoT scenarios. It's designed for ingestion of really millions and millions of messages that comes to the cloud. So that's the way you take data into the cloud, and that's exactly the same technology we use to take the agent data from all this on-premise BizTalk customers into the cloud. So I mentioned this load balancing, the scalability. You don't need to worry about any of these things. It literally took like 1 or 2 days for you to provision a new event hub, get the URL, and then you can post messages. Of course, it's slightly more complex than that, but in a nutshell, you don't need to worry about building that infrastructure. Okay, let's look at some of the challenges what we had to solve from an agent perspective. The number one is it's a two-way communication, because you cannot just leave the agent and it can't be one-way traffic where the agent is only pushing data to us. We should also have the ability to talk to that agent remotely. Things like we should be able to push updates to that agent. We might have okay, today we are collecting 10 metrics. Tomorrow we may want to collect another 50 metrics from that particular agent. So we should have the ability to push the data, push the update to the agent itself, so the agent can get to version 1 to version 1.2 or something like that. Because it's impossible to ask all of your customers, okay, we released a new agent, can you uninstall and reinstall it in hundreds of machines what you have? So that's a problem we solve. And sometimes we may want to do a forced shutdown of that agent, because say if they haven't paid for it, somebody signed up, they installed it, but they never bother to come back to us. We can't have thousands of these orphaned agents sitting and pushing data which we don't know what to do with that. So we need to have a controlled mechanism of okay, you cannot push data unless otherwise you are a valid agent with a valid code. So we can actually send a command and force that agents to stop from that remote Windows server, and we have the capability to do that. And ability to change Event Hub's endpoint. Okay, today we have an Event Hub endpoint, something like production.eventhubs.com, blah, blah. But there might be a possibility in the future we might need to change that Event Hub endpoint itself. Again, we cannot ask them to reinstall it. So we have an ability to do that as well. And also getting local errors and warnings. So there may be some, for example, the agent is not able to fetch data from the local environment, or there may be some internal errors happening. We should have the ability to know okay, that agent is not healthy, because otherwise we may be giving false information. Everything is good in that environment, but because we don't know what's the health of that particular agent, so we can do that as well. And there's it's a ability for self-health as well. The agent should always register themselves every few minutes and say, I'm healthy, I don't have any problems, everything is smooth, and the dashboards will reflect that. So we solve all these problems using these two things. So the web API is our core thing. So what happens is the agent typically communicates to the API frequently and makes sure all those checks, whatever I mentioned, is taken care by using the web API layer. Okay, the Event Hub processor. So if you look at that, this image, we have two Event Hub processors. So there's an Event Hub, and somebody need to pull the data from that and push it to the data layer. And that's the role of those two Event Hub processors. We run two instances. Of course, you want reliability. If one goes down, you wanted to make sure you're still collecting and pushing the data. And also, it's at least, and also you need to take care of not doing duplicates, because the way the Event Hub works is it's not, you don't take the message out of Event Hubs. The message is always there. It's your responsibility to read it carefully and store it somewhere else. So that those things are we taken care of on the Event Hub processor. Okay, let's move on. I think the next topic is one of the interesting topics in a SaaS, any SaaS-based product, storing data on a multi-tenant system, because this is where it gets really interesting. So what are the options, right? Okay, you want to store data from literally thousands of customers into a single place. What options do you have? The option one is you maintain one single database. So you say, let's say like BizTalk 360 customer database, and you have a schema with customer tables and agent tables and all those kind of things. And that could be one gigantic database. And you store all the customer information in that single database. So you will adopt techniques like a column with customer ID, or you might, there are also some interesting, it's very famous in the database world, techniques like sharding, or in a SQL world it's called vertical partitioning, horizontal partitioning, etc. So in that case, you have one gigantic database, all the data gets into that place. This solution is easy from a development point of view because you don't need to worry about anything. It's almost like your standard database access code, and you do it. But operationally, there are a lot of challenges. How are you going to maintain it? The health of the single database. If things goes wrong, it's difficult to manage it. And also from a security point of view, it's so much risk because you have every single data in a single database, and over a period of time, the scalability will also be a problem. Like, you need to imagine like all of a sudden you had a really successful product and you have 1 million users, and you're growing at the rate of, like 10 GB per day or something like that. Then you get into some serious trouble with this model. The second model is what you have it as isolated databases. So you create a database for every single customer, so you don't maintain one single database, but you have like a isolated databases. So when the request comes, you make a lookup and say this particular customer should go to that particular database, and you dump the data in that particular direction. Okay, there is also pros and cons to it. Okay, from a security point of view, it's good because it's all isolated. It's very rare, like you will see somebody else's data. But there are also operational challenges. It's harder to deploy. If you wanted to run a script, you need to run the script against thousands of databases. All those challenges comes into picture. So we decided to go with the isolated database model because that's when you compare the two models, this is slightly better model. And I also when I cover the SQL Elastic Pool, it makes sense why we went ahead with this particular model. So some of the challenges with the isolated database is the number one challenge is how are you going to update the databases? Say you wanted to add a new table or change a column in a table across all the databases. It's a challenge. You need a mechanism to do that in a safe way. And there may be a scenario where you wanted to query the data from a consolidated all the databases. So we want to know the some reports from the entire customer databases. So that's a challenge. And also from a SaaS point of view, if you go and provision like a SQL database straight in Azure, even the lowest one, it costs you like whatever $5 per month or something like that. And if you have a freemium model where you have subscribers, they can get a free account. You don't want to pay like $10 for unused accounts. People just, we all know like people sign up, they never use the product, and you cannot incur the cost at the back of all those unused accounts. You need to take care of that as well. So that's something you need to take into account. And the biggest thing is cost prediction. How are you going to predict it? You are going to provision thousands of databases. What is the costing model going to be? You cannot have a spreadsheet saying, okay, this or a table somewhere saying, okay, this customer is costing us this much in the database allocation. So that's some of the challenges you need to address it. And for us, the solution to all this thing is the Azure SQL Elastic Pool. It's basically Not that many people are aware of this capability. It's purely designed for building a SaaS-based solution in Azure. So when you go to SQL Azure page, there will be two options. You'll have a single database or an elastic pool, and the elastic pool is what we're talking about. So some of the core benefits of Elastic Pool is it's designed purely for SaaS-based applications, and you can have like a mixture of databases. So some customer may be too small, some customer may be big. You can have all different kinds of customers within a single pool. And one of the biggest advantage or benefit for us is the costing. It's actually treated as a single unit, and you pay for a single unit. So you say, I want a standard edition, gives you something like a 1000 eDTUs, and then you pay for that. And then internally, you can have all this fluctuating database sizes, and you don't need to worry about it. You know the monthly cost of, okay, this is how much we are going to pay for the entire pool of databases. And in addition to that, it also comes with a lot of toolings as well. So you can have, like ability to run scripts, you can run a query against it. All those benefits comes out of the box, and also have like a monitoring metrics. You can monitor them and see like whether there's a bad customer in the pool and all those kind of things. And still, you need to be aware of a few restrictions. It's not unlimited pipe. The pool can have only so many databases. So depending on the tier, like I think the basic can have 200 databases, and the standard edition can have something like 400 databases or something like that. So the reason you need to be aware of that is you need to design the solution keeping this in mind as well. Of course, if you have a successful product, you might have thousands of databases. You're not going to limit with the 400 or 500. So you may need to have multiple elastic pools to cater for your solution. So you need to keep that in mind. Cost is something to note. Like we know the whole cloud is a consumption-based model, but that's not always true. Some services, you need to pay for it upfront. Elastic Pool is one such service. So if you say I wanted a standard edition of Elastic Pool, you will start paying something like 300 or 400 pounds per month as a fixed cost. You need to pay for it. So it's not that, this becomes really problematic when you're for a non-production environments, because you need to maintain a dev environment, staging environment. These things will add up very, very quickly and becomes costly. Okay, let's move on.
I have a question about Elastic Pool. It's a cool service, but the shortcoming of that is that if you have 200 databases, it throttles it, so you can't have full load on those simultaneously, right? Have you had any issues of simultaneous usage by customers on the same points, like let's say the last day of the month everyone uses it, and then the Elastic Pool throttles the...
No, that is a different thing. You have like say 1000 eDTUs. That's a consolidated usage. As long as you're not crossing that thing, you will be fine.
Okay, so... But the databases by themselves would offer more, but you organize your pool so that you don't go above.
Yes, it's actually, you can treat it as a one single database. So they work together as a group. Unless otherwise you're not exceeding, the entire group is not exceeding that limit, you're fine. Okay? So let's look at, I mentioned one of the important things you need to look at is the technique for a smooth onboarding process. So we had to do something in the design to make this happen, because the way it works is, okay, you have a bunch of databases. So whenever we provision a customer, we need to allocate a database for them, and the database should have a predefined script, right? Like you have you need to provision tables and store procedures and things like that. And we also need to have like a provision for the web jobs. We need to have a bunch of web jobs. Every customer we need to allocate them. So initially we were actually allocating it only when the user signs up. So when the user come and say they registered the details and they sign up, we actually in the background we were actually provisioning all these things, and it was time consuming. And it's also not reliable. Sometimes it does it in 20 seconds, sometimes it goes for 2 minutes, and the user experience was not was not that great. So what we have done is we have a bunch of core web jobs, and one of the web jobs role is to pre-provision those databases and keep it in a hot state. Both the customer specific web jobs as well as the SQL databases, we keep it pre-provisioned. And so that when the customer signs up, we just need to allocate whatever in the pool and they're ready to go straight away. So this is, it's something, if you go back to the original principles of the SaaS thing, this things comes into picture. It's more of, like a best practice, and you need to make sure, the user can onboard pretty quickly. Okay, let's look into the payment processing. So payment, of course, in any SaaS-based solution, payment is very, very important because you wanted to keep the friction as low as possible. You also need to be aware, there are a lot of regulatory compliance when it comes to the way you can deal with credit cards and payment. So there is probably most of you might know, there is something called PCI compliance. I think the whole of Europe implemented it 2 years ago, 2-3 years ago, something like that. The idea is, we give credit card details all over the place, right? We go to any, Amazon or this and that, and we freely give our credit card details everywhere. So in order to avoid, people in the IT, not misusing those details, the strict compliance in terms of, who can actually store those credit card details in the server. You cannot just put a table and start storing credit card details. So that's why it's important, you work with some third party. That's where this company Stripe come into picture and make sure, it's handled properly, and you don't really store it. When the user puts a credit card in our detail, we just pass it on to them, and they store it safely on their side. So every month when they have a recurring thing, they will take care of that payment, and you don't really store it on your server. And also, you might have noticed, you never be able to edit the credit card detail. You'll always need to add a new one, delete and add a new one. That's also because of the PCI compliance. You cannot, that's because they also don't store the full credit card details. They only store the part of it, hence you cannot edit it. You always, add a new one. And also when it comes to payment, there are a lot of challenges recurring billing. So you need to make sure, you can do the payment on a recurring basis. You need to have the ability to do cancellation. You need the ability to do, upgrade scenario, downgrade scenario. And if you're in Europe, you need to take care of a VAT payment. It's all really, it gets really complicated. So the solution is, you never, you don't even attempt to build it yourself. I've seen people spending a lot of time, building a payment solution by themselves. It's better off, you hand it over to some third parties. And there are a lot of people in the market now. These are the things we chosen, but there are a lot of people who does similar things in the market. So the way it works is, this is how it works. So from Service Bus 360, okay, you come, you put your payment details and say, okay, I'm happy to pay for the service, and then we pass it on to a company called ChargeBee, and we have a structure where you put a payment plan, and then say how often you wanted to get the money, and what is the plan they subscribe to, all those kind of things. And these guys, they contact Stripe, and the Stripe does the payment processing, and the money comes to your bank. So that's a smooth flow. And we can also see there is a line going to the web API. That web API is actually our API. So you need a mechanism for these companies to communicate back to you. Say, we all do that, right? We put our credit card and that got expired. And okay, what happens if the card is expired? You need a mechanism to tell us back, this customer card is expired, and you can have a mechanism how you're going to deal with it. So, we expose the API, and this the ChargeBee guys, they send the messages back frequently. If anything goes wrong, they cannot process the payment or whatever reasons, they keep sending us the message, and we handle it. And we have a web job dedicated for this particular process to take care of all these messages coming back. There's also a process called dunning, which is very popular in payment. So having the rules around like what happens if the first attempt fails, what am I going to do? Okay, I'll try after 2 days. So what happens after that? So you can have like these kind of products will take care of all these complexities, so you don't need to worry about it. Yeah.
We use Stripe as well, and Stripe has at least recurring payments. Is dunning something that Stripe doesn't have?
Yeah, okay. There is a slight overlap. Stripe also does some kind of recurring payments, but it's not sophisticated for a SaaS-based thing. Say, for example, you might have different plans, and you may have like a free trial, and you may have the companies like the one we use is ChargeBee, and there's another company called Recurly. So they're designed for subscription-based billing systems, and they allow to use Stripe as well as your payment gateway.
Okay, so you're saying that ChargeBee you get noticeable benefits from using it?
Yes, it's for subscription-based products. Yes. Okay, well, let's go on to the email processing. I think I briefly mentioned before. It's a pretty straightforward stuff. Don't attempt to build your own email components. Use something like a SendGrid. A SendGrid is very popular and is used by tons and tons of companies. So any email communications, you use a product because the rules are very strict. You might think, you can write 10 lines of code and send an email to somebody, but you will get blacklisted. Your servers will get blacklisted very, very quickly. So there are, very strict compliance, especially in US in terms of whether you have permission to send an email to somebody and all those kind of things. So one of the key things, the modern way of building the solution is, you're outsourcing as much as possible to the specialist in those areas, and you're not trying to build everything yourself. Okay, let's move on. So I'll also want to touch base briefly on the deployment processes, because you can kind of sense it, we have a complex solution. How are we going to manage the deployment? How are we going to make it smooth so that, we can deploy stuff into a staging environment or a development or even production at a controlled fashion. We use the Visual Studio Team Services. All our source control is also in Visual Studio Online. So we don't just one of those modern companies where we can work with our laptops. Basically, we do not have any in-house servers. It's all in the cloud, and everything is in the cloud. So all our source code, everything is in the cloud. So we use the Visual Studio Team Services quite extensively for all our build and deployment processes. So we have multiple build definitions, because we have like a development environment, staging environment, and production environment. And also some of them are, for example, the development build is a complete wipe out. We say, okay, we wanted to get a fresh copy of this into our development server. They will, it will wipe out all the databases. It will wipe out all the jobs. It will do a fresh, clean deployment into a dev environment. And of course, you can't do that in production or staging, etc. So that's why we have multiple different build definitions. So right now we don't have that complete end-to-end continuous deployment. That's something we are working on. As a company, you need to balance it out as well, like how much you're investing on the product development and how much you're investing in all this back-end stuff. So we are just matching it up, as much as possible, and we are constantly evolving as well. So these are some of our build scripts and build actions. What we right now do is somebody manually goes and they just need to queue up the build. It's not, we need to manually do something, but the deployment into an environment is something they go and say, okay, let's kick off this build into production or staging or something like that. So it does, variety of things. We get the latest NuGet packages and whatever is the typical your build and deployment process, we automated it as much as possible. There's lots of resources out there, how to do that. And also you have the options. It's very powerful. Like it has options like parameterize your deployment. You can say like it can take input parameters. It's a box standard thing. Like you can dive deeper and see like how to do that. So the next thing, I also wanted to touch base on the naming convention. All these things will look, very fundamental, but it's also very important you get it right at the first go, because soon you will, I'll open up our Azure portal and show you like how it looks like. We have like, 300 different items, and, if you do not have like a proper naming convention, you are pretty screwed. And, things will be all over the place. So these are, some of the standard stuff we used, but, there is nothing, you can use your own things. But this is some of the things we used. Okay, it's RG for resource group, and if app service, front end, back end monitoring, service bus, event hubs, elastic pool. So you follow some kind of a naming convention, so it's very consistent. And this is at the artifacts level, and we also have a naming convention for subscription. So we have 3 different subscriptions, one for development, one for staging, and one for production, and those also follow some typical naming conventions. Okay, let's move on. Okay, this is something, we initially went with an Active Directory based authentication. So we thought that's a recommended way. Like Azure B2C is what we attempted to do it. So we thought, Service Bus 360, people will associate with their AD to get authenticated, and then they can work on it. But this goes back to the original SaaS principle I mentioned. Your onboarding should be so smooth. And if you tell them you're using AD and the customers need to configure AD to get access to your solution, it's nobody going to use it. And that's we invested quite heavily, and we went with the model. Okay, you need Active Directory, and then okay, you need to authorize our app inside your portal so that we can get you access to the Service Bus 360, and nobody signed up. So we went back to the drawing board. And then we ripped off everything, and then we went back to a simple username password. Okay, you give me an email address and a password to sign up. And then, okay, then you put your Azure Service Bus connection string. That's all. You have full management of your Service Bus resources.
Are you using the ASP.NET membership provider, or have you built your own system?
No, it's a standard ASP.NET provider. Yeah, exactly. I think, but the mechanism is simple username password thing. Yeah.
How flexible do you see it? Do you recommend it for other SaaS services?
I think it's authentication itself is fairly straightforward, right? You need a way to store the user credentials, and then you need to authenticate and issue a token cookie. And I can't see a reason why you can't use it.
I asked the question because are you providing some kind of APIs to other users, and are you providing OAuth 2 authentication?
No, we are not. We don't have any of those at the moment yet.
So basically, you're storing all user stuff on your own account.
Correct. So the password is all encrypted. So we use our own mechanisms to encrypt password, but it's a simple username password table in our core database. Yeah. Okay. Maybe at some point we will go back to Active Directory, because once maybe the user started using it and they wanted to go as a paid customer, then they got the trust in the product, then they will be willing to configure AD and put all those things together. But as a V1 product, where your customer acquisition is more important, you need to keep it as simple as possible.
Have you evaluated the Azure AD B2C scanner?
Sorry, say again, please.
Have you evaluated the Azure AD B2C scanners?
Yeah, that's what we looked into. Yeah, it's B2C, Azure, yeah, Active Directory B2C, yeah. Okay. I think I'm pretty much done with the slides itself, and if I have time, I can go through the portal itself and show you some bits. If anybody is using Service Bus, just give it a try. Okay, let me, I think I have about 10 minutes, is it? Yeah? Okay.
One question.
Yeah.
How do you handle database migrations in your build steps? If you're in the new field to some column or something?
Okay, database upgrade is always tricky, whether you are doing it on-prem anywhere. You know, you need to have like very good processes in place. So you need to know the exact comparison of building, generating the different script. And you also need to make sure, we have rules like you should be safely run that script multiple times. We have a job that takes care of running the script across all the databases, and the script should be written in a way it will not affect anything. And there is no magic. Somebody need to take care of it pretty seriously, like how you're going to upgrade the databases.
Are you using a code first approach, or are you scripting the databases by scripts?
It's a script, simple script, yes.
My question is in relation to the architecture. So you've got the event hubs that take in the messages, and you've got your web API, and then you've got your customer data where you like spread out based on the metadata that you get. And then on the right hand side, I saw one customer web app which was like a big vertical. Is it so that you only have one URL and customer access it like one web app?
Yes, it's exactly. It's a multi-tenant web app. You go to servicebus360.com. You go app.servicebus360.com, and that's a single URL for every single customer.
So the multi-tenancy in such a way that the data is isolated, not the web app.
Yes, the web app is that's how you need to design it. You can't have a web app for each customer. The web app is common for everybody.
So my question comes now that how do you route the credentials to the specific data?
We have this core database. So the core database holds all those login credentials and what customer they belong to and which database. Yes, it all maps inside that core database. Yes. Yeah, it is a hub, but we use internal techniques like caching to maintain that it doesn't always goes to the database and all those techniques. Yeah.
Which kind of caching system? Azure?
We don't use Azure. We use Memcache. Okay. Let me see whether I can.
You had the Key Vault in your presentation. How are you using the Key Vault?
Sorry, which one?
Key Vault?
Key Vault, yeah. It's mainly for the certificates, that's the way you store certificates in Azure. So if you use any SSL certificates, you need to put it into a Key Vault. Okay, this is the app itself. You can see it's just app.servicebus360.com, and you can go access all those queues and topics and stuff like that.
Sarah, we can see it on the screen.
Okay, that's.
Is your company based on Europe or is it based somewhere else?
We are based out of UK. Okay, so that's the app itself. People who are familiar with Service Bus, you can take a look.
We can see it. You have a slide in front of you.
Oh, you can't see it. I thought you were okay. I was. Yeah. Can see now. Okay, so this is basically all our build definitions. This is VSTS stuff, and I can see, if I go into one of those dev ones, I can drill down, and I can see there is something deployed today. We can see, and you can see it took 5 minutes to deploy, and it's just done sometime today. So this is how we are ongoing, just constant deployments going into some environment, and we have about 10 people working full time on this product now. Let me get into Azure resources quickly. This is how this is our all resources, and you can see the number here. So we have about 200 items. So that's why the naming conventions, everything becomes so crucial. It will all add up very, very quickly, and we spend a fortune now with Microsoft with all these things. Okay, I think I'm done. I think 5 minutes left. Okay, thank you very much.